Welcome to The Explainer. Today we are tackling a concept that is absolutely core for anyone studying for the AZ-500 exam or, just working with cloud security in the real world. This is one of those fundamental choices that can seriously make or break your application's security.
So, which is it going to be? Look, this isn't just some minor technical detail. It's a critical decision that directly impacts your app's security, its ability to scale, and honestly, how easy it is to maintain down the road. Getting this right from the very beginning is going to save you a world of headaches later on. So, let's break it all down.
And believe me, those headaches are very, very real. Take a look at this number, 23.77 million. That's the number of secrets leaked on GitHub just this year. It just highlights this massive, industry-wide problem we have with manually managing credentials. Every single one of those leaks is a potential door left wide open for an attacker.
Okay, so here's our game plan. We're going to start by really digging into that secret management headache. Then we'll explore the two main solutions Azure gives us, service principals and managed identities. After that, we'll put them head-to-head, figure out a simple framework for when to use each one, and finally, we'll apply all that knowledge to scenarios you are definitely going to see on the AZ-500 exam.
Right, first things first. Before we can even start to appreciate the solutions, we have to understand the fundamental problem they're built to solve, and trust me, it's a big one. This slide right here really puts it all into perspective. A full 80% of cyber attacks use identity-based techniques. Think about that. Attackers aren't always breaking down firewalls anymore. They're just walking right in the front door using stolen or compromised credentials. This is why how we manage our application identities is one of the most critical parts of modern cloud security.
All right, let's talk about our first solution, the service principal. The easiest way to think about this is like a manually created ID card for your application. It's the classic, very flexible approach that's been around for quite a while.
So put simply, a service principal is an identity for anything that's not a human. We're talking about things like a CI/CD pipeline, a script you're running on a server in your office, or maybe an application hosted in a completely different cloud that needs to talk to Azure. It's the thing that actually gets assigned permissions to do stuff.
But here's the catch, the trade-off. Service principals are incredibly flexible, which is great, but that flexibility comes with a ton of responsibility. You, yes you, have to manually create, store, rotate, and protect its credentials, whether that's a client secret or a certificate. If you mess that up, you're basically just leaving a username and password lying around. It's pretty much just basic authentication with no extra protection. You are completely on the hook for its entire lifecycle. And now for the evolution of that idea. So, if a service principal is that manual ID card you have to constantly worry about, a managed identity is like an automated, building-issued access badge. It's generated for you, it's managed for you, and it only works where it's supposed to.
And this right here is the main benefit. With a managed identity, you, as the developer of the admin, never even see or handle a credential, not once. Azure takes care of the entire lifecycle, creation, rotation, protection, all behind the scenes. This completely eliminates the risk of secrets getting leaked in your code, in config files, or anywhere else. It is a secret list model by its very design.
Now, managed identities are not one size fits all. They actually come in two different flavors. First up, you've got system assigned. This one is created and tied directly to a single Azure resource, like a specific virtual machine or a function app. If you delete that resource, poof, the identity is deleted right along with it. Then you have user assigned, which you create as a separate standalone resource. Its lifecycle is totally independent, and you can assign it to multiple resources, which is awesome for when, say, a whole group of VMs all need the exact same permissions.
Okay, so let's put them side by side. This is where the security picture really becomes crystal clear. Seeing these two approaches together really highlights the huge difference in philosophy and, well, in responsibility.
But before we dive into the comparison table, just let this sink in for a second. According to a report from CyberArk, 93% of organizations had at least 2 identity-related breaches in the last year alone. The stakes for choosing the right identity model are incredibly high. This isn't just some academic exercise. This is real-world risk.
This table, this is pretty much the heart of our entire explainer. Just look at the stark contrast. With service principals, everything is manual. That means a high security risk from leaks and a high management overhead. You have to worry about everything. Now, look at managed identities. It's all automatic. Azure handles it all, which means a low security risk and basically zero management overhead for you. So it really comes down to a trade-off. The go-anywhere flexibility of service principals versus the much, much better automated security of managed identities. So, with all that in mind, how do you actually decide which one to use? When should you reach for one over the other in your projects? Well, it's actually a lot simpler than you might think.
Here it is, the simplest rule of thumb. Location, location, location. If your application or script is running outside of Azure, like in a GitHub Actions pipeline, on an on-premises server, or even in another cloud, it needs a service principal to act as its ambassador to get into Azure. But if your app is running inside Azure and just needs to talk to another Azure resource, a managed identity is almost always the better, more secure, and easier choice. So, inside to inside, managed identity. Outside to inside, service principal.
Okay, let's put this knowledge to the test. For the AZ-500, they're not just going to ask you for definitions, they're going to hit you with real-world scenarios. So let's run through a couple of classic examples to make sure this stuff really sticks. Okay, think back to our rule. Where is the code running? And where is the resource it needs to get to? In this case, it's an Azure function that needs to talk to an Azure Key Vault. That's one Azure resource talking to another Azure resource.
That's exactly right. A system-assigned managed identity is perfect for this. You just go to the function app, flip a switch to enable its identity, then go to the Key Vault access policies and give that identity permissions. That's it. No secrets, no connection strings, no fuss. It's the secure by default option.
All right, scenario number 2. We've got a GitHub Actions workflow. So again, what's the deciding factor? Where is that workflow actually running? Is it inside or outside of the Azure environment? Yep, this is the classic use case for a service principal. GitHub Actions runs on GitHub's infrastructure, which is totally external to Azure. So to authenticate, it needs that manually created ID card, the service principal, to present at Azure's front door. So for your exam prep, just boil it all down to this simple 2-step framework. First, ask yourself, is the workload running inside Azure and talking to another Azure resource? If the answer is yes, your default choice should absolutely be managed identity. If the answer is no because it's running on-prem or in a pipeline somewhere else, then you're going to need a service principal. This logic right here will get you to the right answer almost every single time.
So, choosing the right identity type is a critical first step for securing your apps. But honestly, it's only half the battle. The next and equally important step is applying the principle of least privilege, making sure that identity, whether it's managed or a service principal, has only the exact permissions it needs to do its job, and absolutely nothing more. But hey, that's a topic for another explainer. Thanks for watching.